Hello. Hi, we have Karen and Asheesh here on stage, and they'll talk to us about how to turn your computer into a server. Please welcome.
Why are you behind me? Okay. All right. Hi, I'm Karen. I'm a freelance web developer based in Mountain View, California.
Hi, I'm Asheesh. I'm a security engineer at Eventbrite in San Francisco. Yeah, Eventbrite people in the middle.
Yeah, so this is Turn Your Computer into a Server. It's an introductory level talk. And we have three main goals for this talk that, first, by the end of it, you have a basic understanding of computer networking. You believe that if you have a computer that can access the internet, you can run a server on it, and you have some ideas for how to do so. And finally, you have faith that you can do this and not get immediately hacked or have your computer break or anything terribly awful bad happen. So there are two parts to this talk. The first part is about simple sharing in-progress work or files from your work computer, either within a given network or across networks. And part two, we'll talk about home servers, which is a case where you want it to be up basically all of the time versus just one-off connections, and the specific considerations associated with that use case. So let's imagine a scenario. You're building your first web application in, let's say, Django, and you're going through the tutorial, you run the built-in web server command, and the tutorial tells you to go to this localhost :8000 address in your browser, so you do so, and you see your Django application show up. That's pretty exciting. In fact, you're so excited, and I may or may not have done this myself, you quickly copy and paste the link and send it to your roommate to show off your work. Of course, you quickly realize this isn't going to work. Localhost, that only works on my computer. It's not going to be seen by anybody else. So, okay. Well, you get clever. You're like, well, I know the name of my computer, and so I'll replace localhost with mycomputer.local in the URL, and that's going to work, right? Well, not exactly. And so your roommate still can't see your Django application that you wanted to show off to them. So to figure out why that didn't work and how to fix it, we're going to look at a different tool for basic local sharing, which is called Simple HTTP Server. This is a module comes with Python. You have it on your computer if you have Python. And the way that you use it is you go into a given directory, you run this command, and the files within that directory will be served by default on port 8000. You can specify the port. And this is a really useful tool for viewing and sharing front-end projects, HTML, CSS, JavaScript, or basic file sharing. And what's neat about it is it doesn't just work at localhost :8000. It works even at mycomputer.local :8000. So this works, but the Django built-in server doesn't. So let's compare the two and figure out how we can make the Django built-in server act like this simple HTTP server. So when we look at the log message that we get when we run the simple HTTP server, we get serving HTTP on 0.0.0.0 port 8000. And I don't really know what this 4 zeros thing, but when I compare it to the Django log message that I get, there's a bunch of stuff, and it says it's serving at 127.0.0.1. It doesn't have 0.0.0.0, whatever that is. Well, you might try something clever, and in the run server command, instead of just specifying the port, you might try putting the 40 thing in front of it. So it looks like this. And in the log message, you can see that it's no longer serving at 127. It's serving at 0.0.0.0. Cool. So once you do that, you experiment. You ask your roommate to try again at mycomputer.local, and they see what you see. They see your Django application. That's pretty cool. It works. But we still don't know why, or what 0.0.0.0, which I'm really sick of saying, means. So to explain, we need to discuss, talk about a bit about how ports and interfaces work in computer networking. You might already be familiar with ports, might have heard of them at least. It's easy to conceptualize them as these gateways these entryways into your computer. They're numbered 1 through over 60,000, and so they're not all drawn here. And different applications will listen or bind to different ports. And so we know Django is listening to port 8000, and so it's listening for requests to come in from outside the computer and sending responses, more or less. So that's sort of our basic model of what ports are. The reality is actually a little bit more complicated because you don't just have ports, you also have interfaces. So it really looks more something like this. What an interface is a way that your computer gets online. So here, this computer has 3 interfaces. There's WLAN 2, which is your wireless card. There's ETH1, which is your Ethernet connection. And then there's LO, which is local loopback, which is sort of a virtual interface. You can't actually connect to it from outside. It only works inside your computer. And so each of these interfaces have their own bank of ports. You don't just have one port 8000, you have, in this case, 3. You can see what interfaces your computer has and some information about them if you run the command ifconfig on the command line on most Unix systems. And that will give you some useful information about your computer. So we can see here that the reason why, with the default Django run server setup, your roommate wasn't able to see it, is by default it only binds to port 8000 on the local loopback interface, which you're able to access via localhost. But when your roommate tries, they're connecting over the Wi-Fi. It's checking a completely different port 8000, and nothing's listening there. So they're not able to connect. What the 0.0.0.0 shorthand means is bind to this port on all available interfaces. And so Django does so. And now, you can connect over localhost, and your roommate can connect over Wi-Fi. And if you had people connected on Ethernet, they could get there too. Pretty cool. So great. We've accomplished our first goal. We can show off our work and show off how awesome your Django programming skills are to your roommate, or anyone else who happens to be on the same network. But we have lots of friends who don't live with us, who don't share our Wi-Fi, who are elsewhere on the internet that we also want to show off to. And so we need different tools to be able to communicate with them. In order to understand how to do this, we need to first discuss IP addresses, Internet Protocol addresses. These are what are used for routing on the internet. And there's 2 kinds. The first is private IP addresses, which exist within a given network. So if we imagine that this is your network at home, there's your Wi-Fi router, and there's you and your roommate, and then the router is standing between you and the rest of the internet. Private IP addresses only apply on the left side of this diagram, between you and the router. Certain IP address blocks are assigned to be private addresses. So if you see an address that starts with 192.168, or 172. some stuff, or 10. stuff, that means you're looking at a private address, not a public address. And you can find out what your computer's private IP address is a number of ways. Ifconfig will tell you, for one. Another way is using our simple HTTP server that we were doing before. When you run it, and you access it over localhost, when you look at the log message in the terminal window, you'll see one thing. You'll see a connection from 127.0.0.1 from localhost. But when you connect over mycomputer.local instead, you'll see something else in the logs. You'll see 172, in this case, .27.0.14, and that is your private IP address on the network you're currently connected to. So that's pretty cool. And that means that you can see your roommate's private IP address too. If they connect over this service, you'll see a different IP address belonging to your roommate show up there. Yeah, so that's private IP addresses.
So thanks, Karen. I want to talk a little bit about public services. So websites like Eventbrite, we don't just want to be available inside the office. We want them to be reachable from all over the world. Presumably, same with the kind of websites you guys want to work on also. And to make that happen, we need to talk about public IP addresses, which are IP addresses that will route from anywhere on the internet. So Karen mentioned that IP addresses are what the internet routes messages based on, which means that if you type in something like google.com into your browser, then your browser has to first look up what the address is of google.com so that it can send a message to Google and have the web conversation to show you the web page. And I'll show you what that looks like through a few cartoons. And I think that Lynn Root just gave a talk about DNS. This is going to be much shorter than hers. But therefore, you probably want to look at hers in the videos if you haven't. So briefly, when you want to visit google.com, your browser sends a message to your home router, and it says, hey, what is the address for google.com? Your router may have it stored, may have the answer cached locally. Maybe you've looked this up recently, or maybe this is an address that is based inside your home network, and so it's sort of authoritative for the answer. If not, then it passes that request along to the global DNS service. One of these servers might be Google's, one of these servers might belong to your ISP. Eventually, an answer comes back, which looks like this, and your router then passes that along to you. So now your browser knows what the address is for google.com, so it can then send a message there. But what if you just type this IP address into your address bar? Will it route to Google? Here's a URL with that set up. And it turns out if you visit this, yes, you get the Google homepage. This IP address is just interchangeable for that name in terms of how the packet gets there. So that's great. This means that you can route packets to computers based on names. And if you happen to want to look up a computer based on its name, you can use a command line tool called host, which you can query for some particular name, like google.com, and it will tell you what address corresponds to that.
So, all right. So we've seen real websites have public IP addresses. At least one public IP address is standing up for any website or web service that you're able to access over the wider internet. But your computer, your laptop, almost certainly doesn't have a public IP address. And yet, your computer is still able to communicate with the rest of the internet. It's able to do so because of a trick that your router does, called Network Address Translation, or NAT. And so the way this works, going back to this diagram, here's your network, and your router is standing between the machines on your local network and the rest of the internet. An important thing that your router needs to do is to keep track of whose traffic is whose. You don't want your router sending the packets you requested to your roommate, or vice versa. The way that your router does this is, so let's look at a request. You're sending a packet to a website somewhere on the internet. Looks something like this. There's, among other metadata, there's a to address and a from address. The to address is the public IP address of the website you're trying to access. It ends in a port :80, which is the default port for web services. And the from address is your private IP address, some arbitrary port, which your computer picked out for this particular TCP connection. The details of that aren't important, just that this particular connection has a particular port. So you send that to your router. Your router looks at the packet and takes the from address that you gave it and assigns it to a random unused port number, more or less random, and stores that in the NAT table, which is stored in your router. So here we were assigned this port number 4443. After it does this, it defaces your packet, rewrites it, removes the original from address, and instead writes the router's public IP address, this port that it just assigned you. After it takes your poor defaced packet, it sends it along to the rest of the internet. Hopefully, eventually, you get a response back. And of course, this response isn't obviously sent to you. It's sent to your router's public IP address. And there might have been a lot of requests between when this was sent and when your router gets the response. And so your router needs to figure out, well, where is this packet supposed to ultimately go? It does this by, again, looking in the NAT table based on the port number, and oh, hey, 4443 is here, and it corresponds with this private IP address. It rewrites the packet again to give it your private IP and sends it along to you. And so this is happening each time you're making requests over the network, and as far as you can tell, you're seamlessly connecting with Google, even though the packets are getting changed back and forth by your router. So NAT's pretty useful. The good thing about it is it means multiple devices can share one public IP address. So if you don't have enough public IP addresses, you can still get online, which is pretty neat. I like being online. The bad thing about it is it makes it hard for people outside your network to reach you. Because you don't have a globally accessible address, your router's just like, I don't know where this goes. You can contact your router, but you can't contact computers within the network that the router controls. So we still want to share outside the network, even though we have this difficulty. We need to get around this issue. And there's several ways to do so. The first one we're going to talk about is SSH tunneling. SSH is a protocol you may have heard of. It's a cryptographic protocol that does a lot of things. The thing that we're doing with it is called remote port forwarding. And so in order to do this, the first thing you need is access to a computer somewhere that does have a public IP address. And there's many ways to get access. You might have a university account that has such access, or a Linode, or Amazon EC2 account, or just a friend with a server who's willing to give you SSH access. Once you have this, you connect to the remote machine via SSH. This works like any other internet connection, even if there happens to be NAT in the middle. The protocol also connects whatever port it's using for the connection with the port that your application is running on that you specify. So our application is running on port 8000, so we're making sure to pay attention to it. And similarly, we pick out a port that's currently being unused on the other machine, in this case, port 9999, and connect to there as well. And once we've done this, then people anywhere on the internet can connect to the remote machine's IP address or its domain name if it has one. And on that chosen port, that request will get sent through the SSH tunnel to your laptop, and responses back will go back the same way. The incantation on the command line that does all this looks something like this. -R means do forwarding of traffic. -G means gateway ports. It means use all interfaces, not just local loopback. And then the arguments, we have first the port on the remote machine that we want to use, where stuff is going to be accessible, what interface port combination that we want to be connecting on your local machine, and finally the IP address or domain name for the remote machine that you're connecting to. So great, we've got this URL. We can send it to all of our friends, and they're going to be able to access an application that's running on just your laptop, even behind NAT. All you need to have this access to anywhere on the web is money to pay for a remote server, or a friend who's willing to give you SSH access.
So that works great if you have friends, money, or SSH access. But I want to tell you that life can be okay even if you have none of those. I do notice I'm not super on the Wi-Fi.
Uh-oh.
We'll see about my demo. OK, so there are a couple of services on the net that are willing to act as relays for you in the way like Karen described. There are ngrok and PageKite. ngrok is designed to help you debug your applications. Anyone can set up whatever domain they want, .ngrok.com. And ngrok has a tunnel client that you can use, kind of like the SSH client we saw in Karen's example. PageKite is free for open source developers. It's like $5 a month or something for everyone else. And they have a sort of freedom and privacy bent. But both of these, anyway, are services that we're willing to broker a tunnel for you, and you can borrow a subdomain from them, and it'll put your website online. And if I were online now, I would tell you all to go to this URL. If any of you have your computers open and you are online, and you go there, actually, you'll see a message from ngrok that says, the tunnel is down. It's because the Wi-Fi is down here, sorry. But I do have a Django app running on this machine, and I'm happy to show you this. Oh, whoa, it is working? OK, great. So you can, in fact, go to this. Bizarrely, OK, sure. What if I go to it? Oh, OK, never mind. Great. So we have this great Django app. My apologies for my own stress. Nate Ani, Shimon Rura, and Tony Abu Asaleh have taken the Django tutorial, added a few images, and put it into a Git repo. I'm just running that here. This is a basic polls app. You can go in and view the existing polls. You can wonder which is the most awesome. Didn't this used to say Django?
It did.
Did somebody break into our admin? Nice work, Luke.
Of course they did.
Right. So in that case, I guess lols are better than any of these, and we'll vote. So I'm glad you all agree. But crucially, this website, we'll talk about security soon, Luke. Crucially, refresh. Now I'm afraid to, so I won't. Anyway, Luke here has demonstrated that you can connect to this laptop running right here. The website, even though it says pycon.ngrok.com in the address bar, is actually hosted on my laptop here. And for a while, I thought this seemed, oh, and out of sync.
Uh-oh.
Yeah, okay, cool. Yeah, so anyway, in the 90s, I read this fake news article by a fake person in a fake MIT news magazine about the coming end of addresses on the internet. And I thought, this is a pretty funny thing. And this article hinges on this idea that light fixtures will soon have IP addresses. Yeah, right. But then last year, I went to a friend's apartment, and what I found was a Philips Hue set. You can buy these for $200 at the Apple Store. They're rated 4 out of 5. People seem to like them. And they are internet addressable light fixtures. So it turns out that we are really going to run out of IP version 4 addresses. There aren't enough addresses to go around for all the light bulbs and all the mobile phones in the world. In particular, there's at least 6 billion mobile phones currently deployed, and we don't have that many IP addresses. IP version 4, which is the current most widely used version of the Internet Protocol, gives you 32 bits for an IP address, which means that there can be at most 2 to the 32, or about 4 billion addresses, fewer than the number of mobile phones. But luckily, also in the 90s, perhaps related to that article that I read, they invented a new version of the Internet Protocol, IP version 6. And the addresses are so long that they won't fit on the screen. They're 128 bits long. There are more IP version 6 addresses than there are protons, electrons, neutrons, particles in the universe. So hopefully we're not going to run out this time. And this, of course, means that there's a next generation transition that has to happen. Now, we're Python people here. We're very familiar with next generation transitions that require backwards incompatible changes and asking everyone to change their apps so that they work according to the new standards. And IP version 6 has had at least as much success as Python 3. So a little over a year and a half ago, 14 years after the release of IP version 6, 0.25% of all the traffic to Google's web services were over IP version 6. Not that many. Is Alex Gaynor in here? No, okay. Well, okay, right. Well, I think that he found that recently Python 3 accounts for about 1%. A year or so ago, IP version 6 accounted for about 1% of internet traffic. But IP version 6 is doing even better now. We're up to 1/10 of a quarter of the internet. But the nice thing is this uptick is increasing. And if you don't believe me, I'll show you this graph from Google. You can look this up yourselves, but I'm not just making these up. These are really Google's numbers. So I'm not here just to tell you about IP version 6 because I love it so very much. I'm here to tell you about it because of what it means for getting your computer online. What we've talked about with these tunneling services, you have to borrow a port or a host name from somebody, from a friend on the internet, from ngrok.com, assuming they're online, and they do this complicated rewriting trick. But the way the internet was supposed to work is you just show up, plug your computer in, you get handed an address, and then whatever services you're running are just available to the entire internet. And since IP version 6 has so many addresses, most of those addresses are public, which means if you can find your way to getting a v6 address right now, anyone else who's on the version 6 network can reach you directly without bothering with any tunnels. And there are a few services that will let you do that without asking for permission. My favorite of those is one called Terado. Terado and its protocol called Terado are supported on Windows and Linux systems, and I think there's a Mac port. These let you, even if you're behind some network address translation box, sort of fight your way into getting a version 6 address on your computer. And from that point forward, any services listening on that version 6 virtual interface on your computer are accessible globally without you having to get specific permission or proxying for any particular service. So I'll pass it back to you.
So we've covered a bunch of different ways that you can share applications or files on your laptop with people anywhere in the world or within your network. Usually in use cases where it's just for a limited time, you want to get feedback on something you made, or you just want to show off. So that's part one of this talk. Part two of this talk is about the specific considerations for if you actually want to run a machine that's hosting something full-time from home. So an always-up, caveats, server. So like computer ownership in general, sysadmitting a home server is sometimes fun and exciting. Sometimes things break, sometimes things crash. Hopefully your server never looks like this. But there are some reasons why maintaining a home server and having a dedicated machine for this sort of thing may be worth it for you. So one thing that you can do with a home server is home automation. So maybe you got a Raspberry Pi at last year's PyCon, and you're excited about turning your lights on and off, or you have sensors and you want to track the temperature and humidity in your house, or any number of other things. And you want to be able to access that information not just when you're already at home and you can see that the lights are on, but when you're elsewhere. And so if you're going to do that, having a machine that you can contact from outside your home all the time is really useful. You've got this Django application, and it does something useful for you, and you want to run it all the time. Simple as that. Or there's services that we often use hosted by other people, but you may want to host them yourself for a variety of reasons. Increased control, increased privacy in the current regulatory environment. It's a lot harder for your emails to get snooped if they're literally in your house. And similarly, you can run your own web services at home. So your bookmarks, your RSS, notes, photos, music, all sorts of things. And we have a variety of examples of services that you can host yourself that are open source for those sorts of applications. And the added benefit with those is not just increased privacy and control. Specifically, you don't have to worry about your favorite service getting heartlessly shut down by some large tech conglomerate that just bought the startup that does the thing that you love. If you control it yourself and host it yourself, that's never going to happen unless your household gets bought out. So there's there's benefits to having home servers and being able to do this. And so Asheesh is going to demonstrate one service that.
So if you have that web service at pycon.ngrok.com, you'll remember that it's only available it's available via a tunnel. That means that it could go down if the tunnel fails. What I want to talk with you about is hosting that in a way where your home network makes sure that stays up consistently. So for this demo, we'll view a website at pycon.duckdns.org. And the way to set that up on your home router is what's called home port forwarding. So let's say that this Django app is running on your laptop on port 8000, and you want it to be accessible globally on the internet via port 80, which is the normal web server port. To do that, you would need to configure something that looks a bit like this. You would need to tell your home router, whenever packets arrive destined for port 80, send them over to my computer on port 8000. And you would need to make this rule somehow permanent, not just transitory while a connection gets made. And the way to do this is called port forwarding for your router. And I'll show you what that looks like when packets flow through. When they arrive, they are destined to the router on port 80 because no one on the internet outside of your home knows about your internal address. The router looks at this port forwarding rule and rewrites the packet and sends it off to you. And then your computer will respond naturally through the router. So to configure something like that, you'll need to log into your home Wi-Fi router, and you'll find an interface that looks kind of like this. You'll see there's a bunch of options here. What's important is that the external port is set to 80, the internal port is set to 8000, and the internal IP address is set to the address of your laptop inside the network. There's also this drop-down about TCP and maybe other things. For the purposes of this talk, TCP is the only right answer to that. But for different services, you might choose something else. You can read about those later. In order for people to reach your service, though, they're going to need to know what the address of your router is. So you'll need to know what is my IP? Now, if you just ask this tool ifconfig on your computer, it'll show you your computer's internal IP on your network. But if you actually Google for this question, the Google servers will be happy to tell you. This is actually what Google will say in the search responses. Your public IP address is whatever it is. And if you want to get that automatically through some kind of API, there are services that will let you do that too. So this is great for letting people surf to the router's IP address and get routed by your router to your Django server running inside your network. But if you want to give them some nice domain, like this pycon.duckdns.org address, then you'll need to register that somehow. So there are these so-called dynamic DNS services. For example, DuckDNS. This is their logo, by the way. We had some support questions for them, and they answered them really quickly on their Google Plus community and added some new features for us. They happen to be free. But the cool thing about dynamic DNS services in general is that if your home router's IP address changes for whatever reason, let's say you turn it off and on, and as a result you get assigned a new address, these things make it really easy to update your DNS name with the new address. Oh, so that's all great for letting people route to your server. But if they happen to do a lot with it, if they send you a lot of requests and you happen to respond, there might be some limitations. And there are probably some limitations of just being inside the PyCon network here. So I'll let Karen talk about that.
Yeah, so you can imagine with our Django polls app, if the images on the app we didn't resize them properly, they're full size, huge, and lots of people wanted to use our polls application at once, then that could be kind of a drag. And so with the limitations associated with running a home server, the first one, of course, is bandwidth. Any traffic, either requests to your server or people uploading files to your server, if it's an application that does that, will use up your home bandwidth, which, if to extremes, can interfere with with anyone else on your network surfing or using the internet normally. An important thing to be aware of within that is there's a term called buffer bloat, which is something especially bad with bandwidth that happens if you're dealing with large files, where the large file will get privileged in its loading, but like regular tiny requests will just like get backed up behind it and it'll be terrible. So that's worth Googling. Sensible router configuration can make up for both of these and partially mitigate them. Another thing to be aware of is max connections. So when you're running a service on your computer, many services can really take basically all the connections you can throw at them. If you're hosting some static files with Apache, it'll be fine. The traffic isn't what you have to worry about. What you have to worry about more so is your home router. Most home routers will not put up very well with having hundreds of connections per second coming in, pouring in, sometimes even less than that, depending on the router. What will happen is the NAT table, which we saw earlier in the diagrams, will fill up. And when that happens, then either you just can't make any more connections, or existing connections get dropped on the floor, neither of which is very good. If you've ever had to restart your router after someone on your network used BitTorrent, that's a very similar phenomenon, where too many connections are just making your router break. Your internet service provider may have rules about what you're allowed to do on your network. For example, until relatively recently, Google Fiber's terms of service would not allow you to run a home server. And so that's something to be aware of. Similarly, some ISPs filter certain ports before they even get to your house. Port 25, the default port for email, is blocked both incoming and outgoing by many ISPs. So if you want to host your own email, you're going to have to do some sort of workaround to get around that. And so that's just limitations, things that can go wrong or slow down your home internet and are just kind of a pain. But there's also security considerations where someone defaces your web application or breaks into the database behind your web application and can thus do various things. And so I'm going to let Eventbrite security engineer Asheesh talk about those.
Thanks, although it almost seems like we should have Luke talk about them. Unfortunately, I had the mic. So there are some risks that apply to any service, whether it's running on your home computer or whether it's running on the internet in the cloud, racked in a data center, however. One of the most important things you might care about for your web app is that it actually stay online. What you don't want is for people to show up to your web app, and instead of seeing your beautiful images, they see a broken image icon. This might happen to you if your website gets too popular, for all sorts of reasons. Another problem that might occur is that users might be able to break into each other's information. So this could happen if users have set bad passwords. It could also happen if there's some, like was probably what we did, by the way. Thanks a lot, Shimon and Nate, who set up that demo app. And it also might happen if somebody finds a security bug in the code that you're running. There's something else to be aware of, which is that most frameworks have settings that you can set to make the app be running in a way that's safe for other people to access. Django has a debug equals line that you can set to true or false. If you set it to true, then if you tell that to any Django core contributors, they'll be like, no, how could you do that? Because the documentation says very clearly not to. It says to set it to false if people you don't trust are accessing the site. The thing is that if you're running stuff at home, there's more stuff at risk. If somebody breaks into that service at your house, hypothetically, they could wreak all sorts of havoc. They could change your home Wi-Fi router so that when you go to web pages like eBay, what you see is all the images come back upside down. There's actually a toolkit for this. I'll give you the link afterwards if you want. You can ask me in Q&A. But given that, there are a few considerations that apply specifically to running stuff at home. And they apply to the security of your router and your computer in particular. So if your router has a weak admin password and somebody breaks into the web app or other service that you're running, they can then log into your router, change your password, or reconfigure it. They can also attack other computers. And there was a serious problem recently where a bunch of home network-attached storage, like network hard disk boxes, have been broken into, like tens or hundreds of thousands of them, and we're all mining Bitcoins. So there are some serious risks about this, actually. They can also break into your computer in particular, especially if you're running the web app on your computer. They could then install a keylogger and record all your keystrokes. They could install mouse recorders and see all the things that you're clicking around, and so on. So I want to talk for a bit about how to mitigate those in the few minutes we have left. One of the most important things is to stay up to date. So 10 years ago, I was running a wiki called Twiki. That was my personal website on a home server. And then a few days, at one point, I discovered my server was being used to send out spam. And this was because, basically, I hadn't upgraded my wiki. There was a publicly announced security vulnerability where people could run whatever they want by misusing the version control feature. Not staying up to date, I had to go clean up after that. It was a total mess. Upgrade. The second thing that's the most important to say is that you should take backups. And backups are a way to recover from whatever crazy thing happens to your server. So if you have a live replication set up where any changes made here are automatically synchronized to a second hard disk, then when an attacker breaks in and removes all of your data, that is immediately synchronized to your second hard disk. That's not a backup. You need a way to restore in the case of whatever happens, not that. So there are some particular ways to mitigate other problems, and the key is usually separating concerns. So if you run your home server on your own computer, then at least run it inside a different user account. You can use the users and groups feature so that if they do break into that app, they can't go then look at your browsing history or modify your browser configuration to give the attacker your Gmail password, for example, which they could if it were running as your user account and they had total control. Another thing you can do is separate it so it runs on a different machine. For example, we have a Raspberry Pi at my apartment, thanks to my friend Keegan McAllister, which is responsible for lighting up a grid of LEDs in the living room. And that thing, if somebody breaks into it, you can access it over IRC after all. That thing can't attack my personal data because it's not stored on the Raspberry Pi. Similarly, you can isolate networks. So we've talked a bit about public and private IP addresses. There's another term you can look into called DMZ, which is a way to have a public service on your home network where it can't reach the internal hosts. So then it wouldn't be able to reconfigure your router, even if the attacker had broken in. And there's a lot more you can learn about web security in general. The Open Web App Security Project has this published list of risks called the Top 10 List. I recommend reading that, and we can also talk more after this talk. But having said all this sort of negative stuff, I want to give you this picture from the Chaos Computer Congress. Most of the time, your home server will be fine. There was that one sad story I told about people breaking in. I could have avoided that if I'd upgraded. But I want to tell you one last story about how things can go wrong. And it is where, sophomore year in college, I received a phone call from my mom, and she said, hey, the internet at home is running really slowly. And I said, well, I'm here in Baltimore. You're out there in Rochester, New York. How can I possibly help? Maybe the neighbors are using their Wi-Fi a lot. Maybe there's a new network in town and you need to change the Wi-Fi channel. I don't know. So I hung up. And then I went to read my email, and I couldn't. And I realized my email is hosted in my parents' basement on the home server. So they might be onto something here. And with nothing else to do, I just surfed the web. I found myself at Google. On the Google website, the doodle of the day was the Mandelbrot set. So I clicked there. I happened to click on the Google Images search tab. And then I saw a really familiar picture in the top row of the images search. And this picture, I realized, was a photo of a picture of the Mandelbrot set that my friend Jonathan had put on my home server on his personal hosting account there for a high school project he made in physics class. So I click on that, and lo and behold, it's really slow to load. So that's what was going on there. A bunch of random people were really excited by Google about Mandelbrot sets and tried to load the server page in my parents' basement. Eventually, I logged into that server, and I set up a redirect so that that image got served not from my parents' basement, and everything got handled fine. This is, by and large, one of the worst stories I can tell you. So there's not that much to panic about, especially if you do the kind of separation we talked about. So that's all we have for you today. I hope that we've left you with these takeaways, that you understand basic networking now, that you know that if you're online, you can use tunnels or other mechanisms to run a server, and that you understand the basics of how to do so safely. So with that said, we are happy to take questions. I will say that we have the slides, and we'll soon have the video at this domain here, homeserver.io. Thanks. Oh, ha.
Please come up to the mic.
Oh, ha.
There.
I can go first. Hi, Karen and Asheesh. Thank you so much for your talk. I feel a lot more jazzed about running stuff from my home. I wanted to ask whether you think that standalone appliances like the Freedom Box are things that people would want to look into right now, or do you happen to know whether they're ready? Or do you think that running something from something like a Raspberry Pi or your own tower or laptop would be the best way to go for stuff like hosting your own email, hosting your own photos, stuff like that?
So I can say a bit. Yeah, so the question is about standalone boxes that come pre-configured with home server software, for example, Freedom Box. So I have no particular experience running the Freedom Box software, but in general, it is kind of a Raspberry Pi-like machine that runs a Debian-based operating system. I think that, at least right now, it's good to understand what's going on, and so I think that installing Debian on some computer and learning about log files is a pretty valuable thing to do, and at that point, mostly you aren't gaining that much by running these all-in-one kits. But then again, I've been running Debian since 2001, so you all might have different opinions. Try whatever you want.
I mean, yeah, so I'm excited about the Freedom Box project a lot and similar projects like it. I think everyone should run stuff, but I don't have that much experience with what the experience of running one is like at this point. And I do think it's important to know how the Freedom Box, like any other machine you would run at home, works. So that's sort of my take.
One other quick addition is that whether or not you're using some standard appliance, upgrading matters an extremely large amount. Otherwise, your commercially configured home network appliance storage, network attached storage box will be mining Bitcoins.
I was actually looking into, I'm also running some stuff on my home network, and I was very thrilled a couple of weeks ago when I actually stumbled across UPnP, which seems to simplify a lot of things. So you didn't mention that in your talk, but for example, basically all routers support UPnP, and you can just directly, there's a Python library that you can actually use to talk to your router, and you get the external IP address. You don't even have to go to Google or anything, right? Just from your Python library. And then you can actually say, okay, route this port on the external IP address to this internal IP address, and it's completely automatic. You don't even need to go to some admin interface, and something like this. So would you recommend using that, or is there some inherent, or do you know about it, and do you think it's a good idea to go down this route?
Yeah, so to repeat that, there's a protocol called UPnP, Universal Plug and Play, which lets applications inside your home network configure the router without you logging into the router's admin interface. And the question was, is that great? And the answer is that is great. We didn't mention it here because I've never used it, basically. I'm so used to clicking around and configuring. Also, you can write a Python script to get stuff from it, but it's not integrated into Django or anything else. So you need to be aware of this stuff anyway. But yeah, UPnP can be a shortcut.
Hi guys, thanks for putting this talk together. Great job. Can you talk a little bit more about the duck DNS? Is this more like a free dynamic DNS thing? And how does dynamic DNS compare with SSH tunneling when it comes to home server area?
Should I answer?
Sure, whatever, I don't know. That's the last one.
Yeah, so I guess the distinction between SSH tunneling and dynamic DNS, which maybe we didn't super get at in the talk, is the idea of, do you just want to send people to a random port somewhere on some domain? Is that good enough? Or a subdomain if it's a service like ngrok. Or would you rather have your own domain name that you want to get sent to forward to your home server? And if you're setting that up, you're going to need make sure that your domain name is able to stay in contact with your home IP. And since your router's IP address often changes, sometimes it only changes once a year, sometimes it changes every few weeks, depends on your ISP. Dynamic DNS is necessary just to make sure that your domain name is still pointing at the right thing. And so that's sort of, in general, what a dynamic DNS service does. And so DuckDNS also gives you the domain name. You could use your own domain name with the service as well, I believe.
Via a CNAME record, yeah.
Yeah, okay. Yeah, that's sort of the distinction. Whereas the tunnel is, well, you're going to need a port number for it, and it's going to be on someone else's domain, more or less.
And just to add one other thought, maybe two other quick thoughts. DuckDNS, to summarize, is just a free dynamic DNS service. And also, I find that my SSH tunnels sometimes go down when I'm not looking.
Oh, I see.
And that's why router port forwarding is what I would recommend instead of that if you want to make sure it stays up.
Cool. Thank you so much for an awesome talk.
Thanks.